right, today we are going to do something a little boring, but it's really important to get solar power to work correctly. We have to budget it. We have to understand the amount of power, how much stuff uses, and everything like that. And very, very important to do. Now, what I say you do, get a little lab book, comp book, whatever you want to call it, or pieces of paper and all that, and make a list of the appliances you need and you often use and all that. And then we're going to measure how many watts they use, and then in the course of a day operation, how many kilowatt hours they use. Now there's a third column we're going to call power factor and surge, but for now, don't worry about it. Watts and kilowatt hours. Now I can already hear Steve yelling, "Read numbers, dude, the numbers." Now if you're like Steve and you have issues with numbers, and if you don't know who Steve is, there's a link down in the description and up above. Just click on it and go check out Steve. But the numbers are important, super important. But today we're going to put the numbers together. We're going to show you how to get the numbers and how to understand what they mean, okay? Now, so it's like we say the dishwasher takes 985 watts and it takes 0.92 kilowatt hours. Yes, that still sounds very confusing, but this device, it's called a kilowatt, all right? If you haven't seen these before, I've had this one for 13, 14 years now, long time. Use it for measuring stuff like that. There's a slightly newer one that'll actually remember what it's doing when the power goes out and comes back on. This one, if I unplug it, plug it back in, it resets the counters. So if you have power outages like that, that can be a pain in the butt. Power outages happen here, but so I have a link to the original and the slightly upgraded one. There's other versions of this that are cheaper out there and stuff like that. I haven't used any of them, so I'm not really going to recommend something I haven't used. This I know works and does a good job for me and things like that. If you don't horribly abuse it, it will do a good job for you. Okay. So link in the description if you guys want to order it. It's off Amazon. If you order it, it's $1 or $2 for me. Well, actually not. Probably like 10 cents. Getting a little back for my investment on cameras, mic gear, stuff like that, every penny at a time. But this little device is very handy. This is what lets us plug in an appliance and measure things. Now, for some hardwire appliances, water heaters and stuff like that, let's do something else. But for now, think of stuff that just uses the standard plug. We can plug into this, okay? Now, watts, kilowatt hours, okay? Watts, let's link this back here and say that you have a debit card linked to a bank account, okay? And your debit card has a max single purchase limit, say $2,000, okay? And we're going to call watts the dollars. So the dishwasher, if we go to buy it, it's 985 watts. We can buy it. It fits in the budget. For that purchase, that works. Now, if we combined 3 dishwashers and we tried to purchase it on our magical electric credit card, it would get denied because I said our limit is 2,000. And 985 times 3 is beyond 2,000. Nope, that purchase ain't gonna go through. Now the kilowatt hours are the bank account. Except this bank account, it's not insufficient funds if you go negative, you're in the dark. So when you say, hey, we can buy the dishwasher, but then when you say I'm gonna use it, it drains the batteries and the bank account by a set amount. So say you've got a fridge or a freezer, something like that. Uses 115 watts or $115 on the electric credit card. But let's say the bank account is 10 kilowatt hours. And let's say, you run the dishwasher. Sure, it fits in the bank account, but let's say this uses 20 kilowatt hours from the bank account. Well, guess what? It'll run, but once it gets to 10, lights go out. Okay, so that's sort of the idea. And like I said, I say make a logbook, write everything down. I'm redoing all this stuff because I couldn't find my notes of everything I had for the appliances I used. I was like, you know what, I'll just remeasure everything and I can show everyone all the results, put it in a table, text it up, and make it kind of neat and pretty and go over this in deeper detail. But get a book, write things out, use your tool to figure out what these things mean. Now let's show some real world examples, doing some stuff and comparisons here, okay? All right, so we plug this guy in. So there you go. We should see some nice LCD up there. Yep. All right, so voltage here is 123. It starts off on volts. Amps, right now we got nothing. Now amps we don't really care about. Watts, like I said, that's our electric credit card purchase limit. That's what we're very interested into because that relates to the inverter. It's like we have a 300 watt inverter. That is our 300 watt limit on purchases that we can use. 2000 watt inverter, so on. That's how much you can purchase at once, effectively. And then the size of your batteries, which is related to the purple button here, kilowatt hours, that tells us how much the bank account has available to fund this stuff. Hopefully I'm making a little sense to you guys. Steve, let me know if I'm losing you horrifically. All right, so there we go. Now let's plug something in here and show this off. Now this is just a simple plug. We're gonna turn on a light. Okay, there we go. Make certain the screen looks visible. Yeah, it does. Okay, so we'll go to watts. Okay, so here's our watts. Turn on the light. Got some more light, and is there too much glare? Okay, now you guys can see. So right now this is showing about 12 point something watts. All right, good. So if our credit card has a magic limit of 2,000, this purchase is acceptable. Now let's look at the kilowatt hours. All right. Well, it's not really doing much right now because this is a very small draw. You know, the bank account for using this all the time isn't going to end up to zero very quickly. So, you know, small thing. Let's put something bigger on this. Get a much better idea of what's going on. And since I would like, you know, something nice for the evening, I'm going to have some spiced cider. Let's heat up some hot water in an electric kettle. Whoops, move that around. So here's our electric kettle over here. Here's our thing. All right, plug this guy in. Okay, so get the cords out of the way. All right, we can still see what's going on. Let's turn this on. Whoops, actually push the button. So now we're looking at the wattage. So this one up here is 1500 watts. Well, 1530, okay? This is a big appliance. And yeah, that's actually right when it's supposed to. It's advertised at a 1500 watt appliance, right in line. Okay, and it's already making noise, getting the water heated. Well, let's look at the kilowatt hours. They're starting to tick up. We got 0.01 kilowatt hours already. So we'll let this boil all the way up and I can have myself some cider as we're finishing this presentation. And let's just let it go. All right, we got this thing boiling away and it's done. So as the watts have dropped down to zero, as you guys can see here, let's take a look at the kilowatt hours. 0.12 kilowatt hours. Now this guy, it didn't run very long. I think it took like 4 or 5 minutes or so and made the boiling water. Speaking of which, let me get myself a nice cup of cider here. Now the extra water I'm going to pour into a thermos because I'll make some tea later and enjoy it. More efficient that way. Use the appliance once, good efficiency of resources, so to speak. Now, as you saw, 1500 watts. If we're talking on our electric credit card, where it can do 2,000 for a single purchase, well, not much left to combine with it. You only have, like 500-ish, well, a little under 500, to combine that together to make something else go. So if you tried to run the dishwasher, which is 900 and something watts, or 900 and something dollars, combined with this 1,500 and something dollars, well, it's not going to work. Now what's going to happen? The inverter is going to go into overload. What does that mean? It's going to turn itself off. For the good, well-made inverters, they will just turn themselves off. They won't suddenly explode into balls of fire. Seen some nice videos where other people have seen balls of fire. Very entertaining. I just don't want to ever experience that myself. Things like that. Now, so what you're going to do, get this device, analyze things like that, and look at everything. LED lights, they're real low loads. Microwave, tea kettle, window air conditioner, electric cooktop, all that stuff, heavy duty loads. Now you may not run them for a long time except the air conditioner, but the other ones you may not run them for a long time. So they may be big loads, but the amount they drain out of the bank account isn't super bad. So you can still use them and get stuff done. But persistent long running loads, like say a fridge, that isn't huge, say it's $120 on the electric credit card, but it really drains the bank account, is a problem. So you're budgeting battery capacity or bank account size with the single purchase size or the watt output power of your inverter. And I hope this analogy kind of makes sense. Also think about it. If you hooked a kettle like this uses, all that energy together with your dishwasher, your microwave, you tried to run all three at the same time and they're on the same circuit, the breaker's going to go. So sort of think about that. When you're starting to think about being energy independent, doing stuff on your own, making all your own power, there's a lot of concessions that have to be made in lifestyle, how things are done. And with a little modification in patterns of usage, like don't run a bunch of things together at the exact same time, you can make solar work very well for you and not spend a horrific amount of money. If you try to make everything run solarized, the full scale that we usually use in our houses, with no consequence, we can just use power whichever way we want, however way we want, you're going to spend a fortune. Especially with all the batteries, the inverter, everything. I could easily see you going, $100,000 or more on a system. Yeah, that is a lot of money. So if you're like me and you have to operate within means of budgeting and actually, not having your wife suddenly beat you to death with a cast iron pan for trying to spend that amount of money, or, going to a loan shark for it, you gotta, consider these cases and analyze things and learn how to make things work. I hope this was helpful. If you got questions, need some more explanation, need some answers on this, let me know in the comment section and I'll get back to you guys and give you some answers. But I do hope this gave you a little bit better idea of what to do. And get this guy, this kilowatt, to measure things. Super helpful. All right, everyone. This is Reed, out for now.